NH3 is a base without OH minus. CO2 is a acidic without H plus. So to clarify all these type of the questions, there is a theory is there that is called as a bronsted-lowry concept. The proton donor acceptor concept also we can call it as. So according to the bronsted-lowry concept, any substance or molecule or ion, we are calling it as a acid, means that particular substance must donate the H plus. That means proton donor we are calling it as a acid. Any substance which should accept the proton acceptor, so that is called as a base we are calling. That's it. No OH minus, no H plus, no water, just proton transfer taking place here. But whenever we are talking about that H plus, really H plus exists. Why? Because H plus is a very small in size. When it comes to the charge, electron charge density is more, so it is highly unstable. How it will be exist? Generally we will say that HCl will give the H plus. That means HCl in a water, it will form the H3O plus. H3O plus is the real acid. H plus is not stable, not really exist. So this is called as a hydronium ion we are calling. It is a real acid. So here now acid base is nothing but the proton transfer. So for example, you can see here HCl in a water, it will forms the H3O plus Cl minus, it is forming here. So here HCl I am calling it as a acid, I am calling H2O I am calling it as a base, I am calling. On what basis I can call it as a acid and base? For example, HCl proton donator, no, it here it is donating the proton. HCl converted into Cl minus. That's why I call it as a acid. On what basis I call it as a H2O as a base? H2O accepting the proton from the water, from the acid HCl, it will become the H3O plus. Proton acceptor, according to the bronsted-lowry concept, proton acceptor is called it as a base. That's why I call it as a HCl as a acid, H2O as a base I am calling. One more example. For example, NH3. We know that nitrogen lone pair electron will be there. Water molecule. So here it will form NH4 plus and OH minus. Here NH3 I am calling it as a base, I am calling. Water I am calling it as a acid. How it is possible? H2O there, H2O I am calling it as a base. Here H2O I am calling it as a acid. Same water molecule. Here is the explanation. Here NH3 becomes NH4 plus. That means it is accepting the H plus. There is no OH minus according to the Arrhenius. That's why NH4 plus is a base. How? Because it is accepting the H plus. H2O become OH minus. So it is donor. Proton donor is called as a acid. Already we have learned. So here same water molecule behaves as a same water molecule behaves as a acid, it is behaving, and it is behaving as a base. H2O is a amphoteric. Actually question itself wrong. With respect of whom? In presence of the acid, H2O behaves as a base, it is behaves. In presence of the base, H2O act as a acid. That means any substance, it accept the proton in presence of acid, it is behaves as a base. In presence of the base, it behaves as acid. Such type of the substance we are calling it as a amphoteric substance. We are calling amphoteric substance. That means which can donate H plus, which can accept. So dual role it is behavior. Acceptor of H plus and donor of H plus. It is donating and accepting. For example, you can see H2O. If it is accept the H plus, it will become H3O plus, proton acceptor base H2O. If you remove the one H plus, it will become OH minus. That means here it is act as a base as it is accepting the H plus. H2O, here it is act as a acid as it is donating. Okay. So for example, one more example. H3PO4. Generally it is a acid, right? Behavior of acid. How can you say that acid? If you remove the H plus, it will form the H2PO4 minus, it will form. If I remove one more H plus from this, it will form the H. If it will remove one more HPO4 minus 2, it will form here. For example, if I add one more H plus, it will become H2PO4. That means these both are acting as a amphoteric acting. Amphoteric means it behaves as a acid and dual character. Proton acceptor, proton donor. That means acidic character and basic character. So here one thing have you observed? HCl in the water, it will form Cl minus, NH3, HCl it forming the Cl minus. So HCl is a acid, but Cl minus having the lone pair. So here no, it is forming the one base we are calling, yes, acid. By losing the H plus, it will form the base, but we should call it as a conjugate base, we should call it. That means when acid, if it is remove the H plus, proton removal, by removal of the proton, it will form the conjugate base, it will forms. In case of base we are talking, if it is accept the H plus from the substance, it will form the conjugate acid, it will forms. So here no confusion. If acid removes the H plus, it will form the conjugate base. For example, you can see HCl, remove H plus, Cl minus will form. For example, these are the acid, these are conjugate base. Just to remove the H plus, CH3COO minus. So CH3COO acetic acid I am taking. Remove H plus, CH3COO minus will form here. Okay. HCN, remove one H plus you are removing, it will form the conjugate base, it will forming like this. Okay. So for example, if you take the base, you can take from the base, if you add the one H plus, it will form the conjugate acid. Just one H plus it is accepting. For example, NH3. Just to add one H plus, so it will form the NH4 plus, it is forming. So it is a base, it is a conjugate acid. Okay. So for example, H2O, for H2O you are adding the one H plus, you are adding, it will form the H3O plus. So here it is accepting the proton, that's why this is called as a base. So here it will form the H3O plus, no? So it is called as a conjugate base we are calling. I will do the separate video on the conjugate acid and base also. So here what are the limitation of this theory? When it comes to the limitation of bronsted acid theory, it is limited to only proton based. It talking about only proton reaction. Some of the reactions, for example, you can see BF3 plus NH3. Here also acid bases are there, but here H plus is ignored here. No proton theory, no proton transfer is happen, but acid basis reaction is going on. So this theory fails. Second one, when it comes to the second one, it cannot explain the acidic nature of CO2 and SO2. They show acidic behavior, but no H plus. Okay. Third point, it is a solvent dependent. What is mean by solvent dependent? Mainly this theory work only in the protonic solvent, water and alcohol. Which type of the things we are calling it as a protonic? We are calling protonic, we are calling another name also we can call, that is called it as a protophilic. We are calling solvent which have a greater tendency. What is mean by this? Greater tendency to accept the proton. Accept the proton. This theory works only in the protophilic or protonic solvent. Okay, but this theory will not work in the non-protonic like benzene. Moreover, one more limitation is also is there, does not explain the strength differ, and it will not consider the, it is not talking about the bond strength, it is not talking about structure, it is not talking about, only identifies donor and acceptor. But one advantage is there here. What is the advantage of this theory? Advantage of this theory, NH3 is a base without OH minus, acid base reactions. Okay, NH3 is a base. This theory explain why NH3 is a base. Second one is this theory work in the non-aqueous solutions. Okay, so next theory I will explain about the conjugate base theory. If you like this video,